It wasn't until 1968 that the biggest scientific instrument of its time would help turn theory into fact.
Well, it turned out that friends of mine at the Stanford Linear Accelerator Center were doing an experiment, not intending it, as far as I know, to be a test of the quark idea. They used the electron beam to take an electron micrograph of the proton. And crudely speaking, they found that it was made of 3 objects with the correct charges. So it was taken as a confirmation that the quark idea was correct.
The particle accelerators of the last half-century have uncovered a family of subatomic particles with no discernible internal structure, or at least none that we can see today. The fundamental particles can be arranged into a table, a bit like Mendeleev's. But whereas there are around 100 chemical elements, there are only 12 fundamental particles arranged into 3 families. And in fact, you only need 4, the up and the down quark that make up protons and neutrons, the electron and the electron neutrino, to describe everything in the world around us. The other 2 families are identical in every way to the first, except that they're heavier. And why they're there, nobody knows. But we hope that there may be an even simpler picture. And to find out, we're going to recreate the conditions that were present at the start of the universe, less than a billionth of a second after the Big Bang. How do we recreate those extreme conditions here on Earth? Well, you need one of these, the Large Hadron Collider. 27 kilometres in circumference and filled with over 2,000 superconducting magnets, each at 1.9 Kelvin. That means that they're colder than the space between the stars. Inside here, we accelerate protons to 99.999999% the speed of light before bringing them into collision inside 4 giant detectors. And those detectors take pictures of the collisions 600 million times a second. These are the lengths we have to go to discover the fundamental building blocks of the universe.
And who knows, the next stage in our journey may reveal that our current picture is wrong. The universe may be simpler or very much stranger than we ever imagined.